Okay, so we talked last time about MATLAB graphics, and we covered some topics like how to plot in 2D and 3D, how to animate 2D and 3D graphs. We talked a little bit about handling graphics, how to change the line width, how to change the color of the line, and all of the details. Today we'll talk more about how to handle graphics and talk a little bit about how to create mesh surfaces and contour surfaces. And we just touch base quickly on animation and eventually how to save and export your graphs. After that, we're going to move on to our next chapter. So for the contour plot, of course, we already know XY mesh grid will create the mesh grid, that kind of a clothy mesh grid around the surface. While if you remember in the course, when we say surf, then you're going to see a solid surface. Here, when you say mesh grid, you get those meshes or squares, if you will, that are fabricated through space and time. Now here we're saying function z equal x multiplied or x by e to the power of minus x to the power of 2 minus y to the power of 2. You say mesh c of z, that will create your contour plot. So it's like mesh contour of z. That's the mesh c of z. Mesh alone will create only the mesh, but mesh c will create the contour. Here we have the function ready. So r equals the square root, and you have z equals sine of r. Before we used to say mesh z. What that's going to do for us if we run it, we create a graph that we had it before earlier in the course. That's having mesh, not a solid surface. Now, for cropping a surface, let's say you have a curvature, a certain curvature that you created in the 3D space. Now you want to cut it in half, cut it at a certain section. Imagine as you're having a chainsaw and you want to cut the function at a certain point. What you're going to do, same thing, xy mesh grid, so create a mesh grid surface. You define your function z equal x dot to the exponent of the function. Now c equals z, so still c equal the function. Now what you say, that's where you crop, that's where you cut. You say c of 1 to 11 and 1 to 21. You're saying on the x-axis go 1 to 11, on the y-axis go 1 to 21. Then what you do, nan multiplied by c, so cut at that point. Anything before that point, just remove it out of the shape. So 1 to 11 on the x-axis, 1 to 21 on the y-axis should be cut out of that curve. Then, of course, mesh C, you'll be able to create the mesh. Then you have X label as X-axis, Y label as Y-axis. Now, let's try to do it together. Let me comment these guys. So X and Y mesh grid, you have your Z, C equals Z, and here is your cut. That's where you cut. And the rest is something you know. So you can see the two mountains that we created first, they are now cut at the point where you want it to be cut. Remember how the shape was looking like, two mountains, like mountain and a valley? So now you cut it at a certain point. What if you want to cut the tip of it? What would you do? That's an exercise for you. If you want to cut like, instead of cutting sideways, what if you want to cut on the top, like the top of the mountain?
From the x-axis to that y-axis right there, like 0.4.
This is X, this is Y, and this is Z.
So Z right there at 0.4.
Try it on your own, see what happens, see if you can cut it differently. What you do, so you can, so again, let's see it how it was before the cut. This is how it was before the cut, right? Then we cut it along, like as if you make this facing you this way, then you cut over here, then you had that. What if I want to cut the tip, like at 0.3? I want to cut at 0.3 to 0.5. What should I do? That's an exercise for you. Try to play with it and see how you're going to do it that way. But yeah, again, if you bring back the C, then you can see what happened to that exact shape. Now it's cut at the exact moment at the X and Y that you told him to do. That's another property that you can keep in mind and you can use whenever needed. Now, visualizing vector fields, probably you're not very advanced through physics, but when you are trying to have a stress analysis or you try to have your electromagnetic course, if you are into electrical field, electrical engineering field, then they care about how is the magnetic field behaving around certain area. It's a big point of research. Many researchers in the electrical engineering using that kind of representation. For us as mechanical engineering, we care about the most used part is either force analysis or stress analysis. You have a chair, there's a force applied to it. As we're going to learn moving forward in the courses using SolidWorks and analysis, there's a stress applied at that point. You want to know how does the force, where the force is combined and where it's distributed. So you can represent that as those arrows that you see here. So that could be very helpful for you. And how would you do that? Of course, x and y, mesh grid, we know it. Define your function. In this case, they're saying dx equal to x. It's like derivative of x, but dx is a function. It's like you say a equals to x and b equals dx. So it's the same thing, you know, or dy would equal dx or dy equals b in case you decided to go with b instead of dx. Now you say if dy for all points should equal 1, and you say contour x, y, and the function v. So he will draw the contour for it. Hold on. Then you use the function quiver or quiver. That's the function which brings the arrows into your graph. So the arrows will follow the trend of your graph. Let's jump into MATLAB and see how we're gonna apply it together. Of course, we had the grid, we had the function v, had dx and dy. Again, those representing derivative, but you can say this is a equal to x, the same concept. Now, dy is the same size as dx by making all R1s and the same size. Do the contour to create a contour, and quiver will create the arrows for you. If you run it, then you got this graph with all those directional arrows or field arrows, if you will. And if you comment out the quiver, what's going to happen, obviously, then you got to draw that as a contour without any arrows. So the quiver is the function that will allow you to see the arrows, and that would be helpful for you if you decided to move on with research, especially in mechanical engineering, as I mentioned, in stress analysis and strain analysis and all that kind of stuff. Now, visualizing matrices, of course, there is nothing called as visualizing a matrix. Nobody can tell you in your math class or your calculus, draw this matrix for me. We know matrix is like rows versus columns, 3 rows and 3 columns matrix, 2 rows and 2 columns matrix. It represents numbers. Then it's not a function that you can represent in curves, right? So what's going on here? Basically, we are having a convention when we are having a number 1, then we give it 1 bar. When you have number 2, we have 2 bars. So you make that kind of bar representation for the matrix. So what's going on here? All those you see as small flat squares, those are like 0 squares. So if you have a matrix from 4 numbers, this is 1, this is 2, and this is 1, and this is 0. 0 will keep it the same. 1 will give it a little bar, like it's a little bar above the floor, you know. 2 will have 2 bars, and so on. There's nothing called as matrix representation, but it's good to be able to do that. Sometimes you have a complex matrix, you want to know how it's behaving, you have too much data, then you could visualize the numbers. That could be helpful at some stations. Now, how we do that? You go defining your matrix, then you're trying to tell him when you're going to have zeros and when you're going to have ones along this big matrix. Then you tell him mesh A. So mesh for me, the matrix A. If we run that, then we're going to have our matrix on the X, Y, Z, as you can see here. See the bars in my example, he represent as triangles for the values. As simple as that, guys. I'm not sure if that would be helpful for you, but it's good to know. Now, there is another option in MATLAB that you can do 3D graph rotation. Sometimes when you use the function plot, you got to look at the graph, especially when you draw a 3D shape as the one we see for the 2 humps. Maybe sometimes you want to look at side view, top view, left view. You can imagine MATLAB is looking at it as if you have an object and there's a camera. So if you want the object or the curve to show up in the graph from the top, then you can tell MATLAB, hey, rotate your x-axis camera 90 degrees. So it will see it top. Or rotate it 30 degrees to have an angle. Or rotate it 40 degrees. So it's not the object who rotate, it's the camera, based on the logic of MATLAB. But many other softwares or coding softwares or visual softwares, it's always the object who move. It will be easier than saying move the camera. So the function for that is the function, of course, view. So you can define, here we have AZ, which is the azimuth, and we have EL as the elevation. So you're telling him at what elevation the camera should be, at what angle on the X, Y axis. You know, there's other axes than X, Y, Z. There's pitch, yaw, and pitch, roll, and yaw. That's used more in aviation. What does azimuth mean? It's basically the roll. So if you have an airplane over here, now the airplane have an axis. If you roll it, that's called roll axis. That's in aviation. Now that's the center. If you go this and this above the center, that's called pitching. So if the airplane is going this way, that's called pitch angle. And rolling is rolling angle. Now if the airplane go right and left this way, that's called yawing. So if the airplane is going in or going out around the center, that would be yaw. So just in case you're wondering what's this AZ in this case. So he defined how the angle is going, minus 37 angle, increment 15 to minus 37 plus the 360. Mesh A means create the mesh for my matrix and make the view for azimuth and elevation. And we have a for loop, so it means he will show you continuously more views than one. But in many cases, this application is very helpful if you need to show the graph at a certain exact single angle. But in this case, he can rotate for each angle you choose in your for loop. We made an increment for that angle. He's showing you the object as a rotating object. Again, this is not the best way to animate stuff in MATLAB, but I would say you can rotate the graph to make it look at a certain angle if you want to do that. Now, graphic handlers, we learned before, we can say plot X and Y, then he will plot it for you. Now, if you say a certain function equals plot X and Y, in this way you are creating a handle for the plot. When you say A equals plot X and Y, then A is the handler for plot X and Y. You can say X label for A, then you can say line width for A. So that's A is your handler for your graph in simple graphs or in simple terms. Now you can see here, you can have a handler for the label, like X label of X, you can just have H of X as the handler for the labels only. And that's nice if you want to automate or change many things of the graph altogether. So you can sum them all under one function and change them at one shot. Three functions that will give you some information about handler. You can have the function GCF. It will get the handle of the current figure. So in this case, we have HF equals GCF, and GCA will get the handle of the current axis, and GCO will get the handle of the current graphic object. Okay, move on. Positioning figures. Now, when you run your plot X and Y, the figures show wherever you want, right? Sometimes to the right, sometimes left, sometimes centered. You can control where the graph will show on the screen. It's up to you. How you do that? Firstly, you can ask MATLAB, get me the resolution of my current screen. I'm using a laptop, you're using a PC, so he can tell you what's the resolution of your screen by following the function get 0, then screen size. Now you can say set 0 units and normalized. In this case, he assumes your screen is 1 by 1. Why that's helpful? If you want the graph to be in the second half of the screen, then you can say make the position of the screen 0.5 on X, 0.5 on Y, instead of having the exact resolution if you're not aware of how much resolution in that screen. So normalize will be helpful in that case. And of course, animation, Comet and Comet 3 is your go-to for main hardcore animation, if you will. To our MATLAB here, and let's have positioning figures. So you have set 0 units and normalize. So you normalize the screen. H1 will be a handler for figure, having units and normalized, and you make the visibility off. For H2, he handle the figure, units, normalized, and visible off. Now he says set H1, like graph 1, at the position 0.05 out of 1, 0.05 of the screen. Then 0.5, then 0.45, and 0.35, and say visible on, means show me the graph. H2, you position it at 0.53, 0.5, 0.45, and 0.35. If you run it, you're going to have two graphs, have nothing in it, but just to show you the concept. So figure 1 is showed up at this exact point, and figure 2 showed here. You can choose to show 4 figures in certain applications. Sometimes maybe you want one of them to on, one to off, if it's serving a certain purpose in your graph or in your code. Of course, you can go so far with MATLAB and create animations for the solar system, if you will. You can have it to be only animated or accurate. It could be very helpful. As I mentioned, many researchers using MATLAB for the ease of use of numbers, and it had some graphical power. You know, it's not an animation software, but if you want things following a certain mathematical path, you want to know how a certain pattern is going, you are not sure about a certain equation, maybe you think you found out a new equation for something, then you can try to test it out through MATLAB. That's the longest way to do it, but if you're doing mathematics and research, that's the most reliable way that gives you something meaningful. Exporting graphs, go to your code and try to make MATLAB make a graph for you. Then you can go to File and Save. Then you save the graph as a GPG, as a PNG, as many file extensions as you need. Of course, I suppose or I suggest for you, take that from there when you create the GPG, put it in Word document, put it in PowerPoint, put it in Photoshop, Illustrator, anywhere else. Just take it there and stop there. And for printing the graph, of course, File and Print, you can choose black and white, and you can choose many options. Now, for the last graph that we had, so I can go to File, and I can go to Save As. As you can see, he have it as FIG, which is a figure. I can choose something else. I believe figure will not open with you in Windows normally, or in Mac, so you can choose JPEG image. You can choose it as a PBM, or you can choose it as PDF, PNG, SVG, TIF, and so on. I believe JPEG would serve most of your purposes. Printing, of course, you can go export setup or print preview, or you print. When you print, he will take you to your printers if you have any available, and you can even print it as a PDF, by the way, if you want to. But you choose your printer, you choose presets, you choose coloring, and all those details. Now, coding errors, of course, as you're coding, you will keep getting errors. Most successful or advanced coders, regardless of language, having errors every day. That's totally normal. Now, wanna try to recognize types of error we have and avoid different sorts of errors and pitfalls. Now, for debugging, when you are coding, then you get an error that's called between the programming community as a bug. Bug means there's an error on your software, prevent it from running, or a bug that is leading your program to give you the final result. Maybe your program is running, but still have a bug that is causing him not to run as you expected him to run. In history, today, you know, computers are made out of millions of transistors as a piece of history. Now, transistors are in nanometer size. So you can imagine this as a transistor. Inside the transistor, if you look in the microscope, there is many circuit ways, or copper lines, if you will, or gold lines to be more accurate. Those distribute where the electrons go along the computer as needed. In the big picture, nothing precise here, but just to clarify, so you have your electrons going in, and at a certain way they're going out. Now you have another transistor here and another transistor here, and you got the computer, which is the brain, controlling those guys. You can imagine controlling wirelessly or controlling through wire. Now the electron come in. Let's say this transistor is responsible to turn on the fan in this room, and this transistor is responsible to turn off the light in the room. Now, computer, through transistors, those transistors can be seen as valves. You can imagine them as electron valves. So I can choose when to open this, and I can choose when to send the electron here and when to send the electron here. So maybe in your code you say, okay, if A greater than B, open the fan. So you let the electron go to the transistor, which will allow him to run the fan. If A less than B, or less than 1, go to transistor 2. In this case, he's gonna turn off the computer. In the past, questioning before the PCs, they look as big as this room. Why? Because transistors were as big as a lamp. They were looking almost like a lamp. So the transistor or the gates were as big as this. So the electron will come in here. There's a certain mechanical circuit here, and he will go this way. When you used to run the code badly, then you had an error as we had now. What would happen? This transistor will short circuit. It will officially burn. It will short circuit. You know, like you run the wrong electron in the wrong time. So he had a short circuit. So they had to replace the transistor because of that code error. That, what they call before charcoaling, when you see a black component, that's charcoal component. And the other word for that is bug. So when they say we had a bug, so one of the transistors is burned. That word kept living with us until today. We still have the word bug, and debugging means finding where's the issue in your code which used to burn the transistor, but now, thankfully, they are repeatable and they don't burn, so that's a good thing. Types of coding. First type is typing related error, which is known as syntax error. Anything typing related is called syntax error. The other one, which is the stinkier one, I would say, is the logic error. It means everything runs and the program bring out an output in many cases, but your numbers doesn't look like what you want. So that's a logic error. Then there's another one called rounding error. That's mathematical related. Sometimes you're rounding numbers, like small, little, minimal numbers. You round them over and over again until your final result is way far from the reality. Now there's more errors as runtime error, and there is compilation error. Compilation error, sometimes you have a certain sequence in your code. Maybe you identify a function after you already call it. If you call the function before identifying him, you know MATLAB will tell you, oh, what do you mean by A? I don't know what's A. So you got to identify A first. So that's compilation. He prevents you from compiling or running the code while it's a minimal problem. It could be a syntax problem as well. Runtime error, that's something you see while you are typing and searching online. They tell you, some websites tell you runtime error. It means he called a server that you asked him to call, but the server is not there or disconnected or offline. So that's runtime error. You wouldn't get that in MATLAB unless you're working maybe as we used to do with vehicle. We used to use MATLAB connected to vehicle connected to a server. If the server is not available or not online or doing something bad or hanging, then he's gonna say runtime error, but it's most likely you wouldn't get this in a while. An example of syntax error, let's go to our code over here. So if you say 2 multiplied by open parentheses 1 plus 3, and you run it, what's gonna happen? Let me clear the program here. What's gonna happen? What's gonna happen? Add it to path. Invalid expression. So you have here a big or general syntax error. What's going on here? Of course, you know you should close the parentheses. That way he would run. Let's run it again. Now he gave us the answer. Another type of syntax error, you know the word disp. Like in MATLAB, disp, open parentheses, open brackets, then between single quotation, the answer is num to string of 2. If you run it this way, what's going to happen? He gave you the statement is incomplete, which is a syntax error. What we are missing here, you want to remember the general form for the function disp, which should open and close brackets and parentheses. If we rerun it, then you get back the answer is 2. So you need to know what's the general form to be able to identify. Thankfully, MATLAB is one of the best languages in identify syntax error in specific because they call for you which line the issue was. Sometimes he mislead you because there's more than one issue, or on the same line there is more than one issue. So that would be confusing as your code getting bigger. Okay, that's that. And of course, if you need to know what's the last error message that MATLAB gave you can use the function LASTERR. That's going to tell you what was your last error. That could be helpful once in a blue moon. Now, another error what's considered as syntax error is having, we had that before in vectors, you have 2 vectors, they're not the same size. In this case, you get an error. MATLAB will tell you they are not the same size vectors, but sometimes you need to go back and make sure your vectors are not the same. Otherwise, you get an error. Sometimes you don't know where it's coming from. Vector size error. So here we have x equals 0 with an increment pi over 20 to 3 pi. And y equals sine of x. Then x, you give him a new values, 0 to pi over 40 increment to 3 pi. Then you say plot x and y for me. So if you do that, let's try to run it. Now he say error vectors must be the same length. What happened here? You had x identified and y identified. They both had the same vector size, but then you updated the vector size of x after you called y. So in this case, two vectors are different. Now, if we comment out the y here and call the y after the new x updated, in this case, they will be both same size vectors, then you will be able to see the graph for the x versus y, plotting that in 2D. Now, logic error, again, we said it's an error. Not necessarily will stop your program. It may not, but it's an error based on the logic. Like the program output doesn't make sense. If you say 1 plus 1, then MATLAB give you back 4, what happened? There's something wrong. So best practices, since one of the famous and most painful errors is the logic error, there's best practices to do your investigation. Of course, we learn how to do section break and break down the program. Go to what you know and run it alone. Try to run it alone, or give fake input numbers sometimes just to know, is it running as anticipated? Then do section break, do commenting out as needed. Then try to run the program in special cases as you know the answers. And if you don't know any exact answer, try to use the insight into the problem and check whether the answers seem to be in the right order or no. Check the sequence and try to work through the program by hand. If you are trying to solve a mathematical problem, see if you do it by hand. If it's an integration, do it by hand and see if it's getting you the right answer. If the answer is different, then you can investigate going from there. Now, rounding error, again, it's a mathematical error. If you keep rounding the numbers more and more without controlling what type of numbers or level of accuracy you're using, you get sometimes rounding error if your code is mathematical intensive. Now, logical error, let's have a logical error here. I created this one, A equals input. He's telling you input your name. Now, I say if A greater or equal to 0, display negative number, else display positive number. Let's run it. Now, input your number. My number is 2. He's telling me, oh, 2 is negative number. No, 2 is not negative number. What's going on? Okay, let's run it again. Input your number, -3. -3. He's saying -3 positive number. So it's running, but there is a problem. No, that's not what I want. Oh, wait, I should say here A less or equal to 0, or A less than 0 only if you want. Then he will have negative, else he will have positive. See, just one sign different created for you a logical problem. As simple as that. Now, if you run it, number 4 should be positive. Yes, it is positive. Life is good. Move on. Micro project that we're going to solve it together. Try to tell me, is it a syntax error? Is it a logical error?